and now we'll move on to step 7, determining the number of ventilators in the reservoirs. There are a number of factors that must be taken into account when carrying out this step, so let's look at the first factor. It must be ensured that the exhaust capacity provided is at least the natural or mechanical exhaust rate that is required. If the installed capacity is greater than the required capacity, then the base of the smoke layer will simply remain a little higher in the reservoir. For natural ventilation, the required exhaust capacity will be a specified area of ventilation, and for mechanical, it will be a volumetric flow rate. In the last step, step 6, we calculated required ventilation areas and mechanical extraction rates, and now let's suppose, for example, that we need 12.6 square metres of aerodynamic free ventilation per reservoir. Let's look at how this can be provided. It cannot be provided as a single ventilator, as ventilators don't generally get made that large. An aerodynamic free area of, for example, 12.6 square metres equates to a geometric area, or an actual measured area, of 12.6 divided by 0.6, which equals 21 square metres. We've used the figure of 0.6 here, or 60%, as the coefficient of ventilation, and we do this because the ventilators are not 100% efficient. So how big are ventilators? Well, they're not normally larger than about 6 square metres in geometric area, with dimensions not normally exceeding 3 or 4 metres in either direction. As mentioned earlier, to determine the effective area of a vent, otherwise called the aerodynamic free area, it's necessary to multiply the geometric area by the coefficient of ventilation, which is usually about 0.6 or 60%.